Okay, in this video, I talk about optimization, specifically a technique within optimization called linear programming. In the programming, don't worry so much about that term. The linear, what that means to you is that all of our equations will be linear expressions. And the easiest way to think of that is that when we build models in Excel, we are not allowed to use functions that create nonlinear expressions. So you can't use the if statement. You can't use a max statement. Most of the functions in Excel, like a VLOOKUP, that is highly nonlinear, you cannot use them. So we need to write algebraic expressions, and we need to write linear algebraic expressions, and we're going to learn how to do that in Excel. So again, linear programming, it is an optimization technique. And when I mean optimal, that means it's trying to find the best answer. You set up a math model, in our case, using spreadsheets, and then you tell the model to solve the problem, and it will evaluate all the different combinations to come up with the very best answer, subject to some limitations or constraints. So you can see these are some of the applications. Optimal production schedules, that's sort of what we're going to be talking about in planning, but you can use it in finance, you can use it in blending problems, you can use it for location problems. So it's got a lot of applications beyond operations. There's three things you need to think about, and when we go through our models, we'll think of these as three things. You always have to have decision variables. These are your unknowns. So if you remember in junior high and high school, when you took algebra and you had your x's were your unknowns. You've always got to have within Excel certain cells that are going to be representing the values that you want the model to determine the answer. Then once you've defined your decision variables, you can establish some function, some Excel formula, Excel-based expression that is a function of these decision variables that you're trying to make really, really big or small. We can either maximize profit or minimize cost. And you only get one of them per problem. And then also we have reality that comes into place, because if we don't have any restrictions, then the answer is usually make an infinite number. Well, we know that we've always got resource limitations or time limitations, and because of that, we have to, within the model, build constraints. So here's the steps. The first thing you do is define your decision variables. Then you've got to have an objective function, and then you list your constraints. Generally, these constraints are inequalities. So usually it's a less than or equal to, a greater than or equal to, or a strictly equal to. We also, for the most part, don't generate negative numbers on things. So when we're using the model to determine how many things to make, we have to have that to be at least greater than or equal to 0. Okay, that's enough, and I'm going to go into Excel and show you how we get started. So when you open up a spreadsheet, what you're going to need to do, and I think you can do this on a Mac or a Windows machine, is go under File, Options, go to the add-ins, go to the Go, and what you're looking for is the Solver add-in, this one, Solver add-in. And how you know that it's available or it's there is that if you have it, then under Data, under the Data worksheet over to the right, you should see Solver. And when you click on this, this brings up a form. And remember the three things you have to do. You've got to be able to establish, first of all, to me the most important thing is that you've got to define which cells are your decision variables. That's what you do here. The next thing you do is define your objective that you're either trying to minimize, maximize, and that's a single cell that usually represents a formula. And then we can add constraints. These are inequalities. And again, we're going to do an example in other videos. This is just kind of an introduction. The last thing that you need to do before you hit solve, the last thing you need to do is the solving method. We are not going to, at least initially, worry about using a nonlinear solver. Nonlinear solvers are always inferior to linear solvers. But again, to do a linear solver, your equations have to be linear expressions. So the method that we're going to use is the LP method, which is, it's called the simplex method. That's just the name of it. But the simplex method is used to solve linear programming models or problems where all the expressions are linear expressions. So that's the one you want. So once you set this up, set this up, set this up, you can hit solve and you'll get an answer. And the next set of videos go through some examples. Thanks.